Sounds like this debate's been raging since the 30s amongst geologists. Is this one of the big mysteries in like North American geology?
I would think so. Yeah, I think so for sure. And if this is caused by an impact, this would have been a huge, huge deal. We know for sure that there was a major impact 786,000 years ago that we don't know where it happened. The guy who has a PhD in physics, he is on board with everything we've said. He thinks the physics doesn't support them being solid when they hit the ground, that they would have burst before they hit the ground. They call them Carolina Bays because of the bay trees that grow inside them. They all kind of point to the same source. They say that science changes one funeral at a time.
In case you've never heard of a Carolina Bay, let me give you a little intro. There are like 75 to 500,000 perfect ellipses smattered across the United States. I'm being for real. If you haven't heard of this, they're called Carolina Bays. Something happened at some period in the past, we don't know when, to cause all of these perfect ellipses, and here's a really strange detail, that seem to point towards an epicenter. They all point like in the same direction, scattered across the U.S. Look into it, you might have one near you. Chris Cottrell is a high school science teacher from the state of Georgia who's been studying this. Thank goodness for him, because someone needs to be studying this. He has some new details. Why would we have some new details now if we've been debating it since the 1930s after we first observed them from airplanes? It's because he now can use LiDAR. So Chris has the photos to prove it, and he's got some new information for us. If you're curious at all about Carolina Bays, welcome to the Austin and Matt podcast.
Dang.
Well, I want to start at 10,000 feet. So my understanding of how the world began was 65 million years ago. An asteroid maybe hit the Yucatan. And there's a lot of, and then much, much later humans came. And my understanding is there's a lot of stories of a great flood. In like 200 different cultures, there's a great flood, Noah's flood. And what people are saying now, people like Graham Hancock, I think, are saying that that was like 12,000 years ago. And there are some geologists who have come out and said, well, the Carolina Bays, which are these odd swamp-looking things, in my mind, scattered around the United States, may have been a result of an impact that actually blasted the whole U.S. and then created a bit, sort of like introduced a bunch of energy into Earth, and it started melting everything. And that's where the latest ice age would have ended, kind of. And so that's my understanding of Carolina Bays and what's called the Younger Dryas impact theory.
Yeah. And to be honest, I don't know how much the two are related. But it is a neat way to pull people in to those stories. In fact, when I first learned about a lot of this stuff as well, it was from a friend of mine who was, he was a Bible thumping creationist, and he heard the 2015 Joe Rogan and Randall Carlson podcasts, and he was like, "Look at this! You got to see this! I mean, global floods, man! It happened!" And I was actually finishing my master's degree in geoscience from Mississippi State, and a lot of what Randall Carlson was talking about, matched what I was learning about in graduate level geology classes. I was like, there might be something to this, and so that kind of like fed me back into that rabbit hole of looking into a lot of that geology and seeing how it matches up with a lot of that stuff. And I don't know, but I know that where it took me with the Carolina Bays, this is a pretty fascinating story. There's really interesting, topics that come up with that.
So what did you do? You hear about Carolina Bays. We're down here in Florida. There's some around here and all up the East Coast.
Yeah.
So what did you do?
Yeah, we're in coastal Georgia, and this is about the lowest extent of where you start finding them. About maybe 45 minutes west of here, you start finding a couple Carolina Bays here and there. They call them Carolina Bays because of the bay trees that grow inside them. It's not like a water bay, which a lot of people, that confuses a lot of people. But they're these elliptical shaped depressions. And once you get into the Carolinas, the terrain is covered in these elliptical shaped depressions all the way through the Carolinas. So the unconsolidated coastal plain is speckled from top to bottom with these Carolina Bays.
And how big are they?
They could be anywhere from, a couple hundred meters to a couple kilometers, like miles wide. Yeah, some of them are huge. There's whole towns and cities within some of these Carolina Bays. They're really large.
How deep are they?
They're really shallow. That's the other thing. They're really large and really shallow. And as you were, alluding a minute ago, we do think that they're impact related. Not quite from the fragments of a comet breaking up or things like that, but we think that there was an impact into an ice sheet. and it was the ejecta from that ice sheet that came launched from that source that we think was over Michigan, and the ice came crashing back down, and that's what created these elliptical shaped depressions all over the coast. And I mean, like I said, when LiDAR became a thing, that should have changed a lot of opinions about Carolina Bays, because previous to that, they always thought that they were, well, it's a complex story, because back in the 30s when they first had aerial flight, they started noticing these Carolina Bays, and they instantly thought what you were talking about, that there was a huge explosion in the sky, and it was comets of asteroids or whatever, meteors that were coming crashing down to the earth. But they all have a certain directionality to them. They all kind of point to the same source. And then, like I said, this is back in the 30s, but they never found fragments of comets within them. They never found, any kind of meteor fragments, anything large enough to draw enough attention to it. And so, like geology or geologists do, they're like, well, then it must be something more mundane. It must be gradual. It must be something that took thousands and thousands of years for these things to create. And that's the direction that they went. And so they, for a long time, they say that they're ponds. They were all ponds, and they were swirling around in water during the Ice Age. And that's what created these elliptical shapes. And they compare them a lot to the ones in Alaska. They have oriented lakes in Alaska. But they're not the same thing. And like I said, now we have LiDAR, and we can actually use technology of today to say, that's not what happened. These things are way too mathematically elliptical. They're way too similar to each other, that gradual processes can't do that. It's just that it can't happen.
So what did you do when you heard about the Carolina Bays? How do you go about researching this? You're finishing your master's,
Mm-hmm.
and what do you do?
So I first heard about Carolina Bays, 25 years ago.
Okay.
Yeah, it had to have been 99, 2000 when I was going to college in South Georgia. I went to a smaller school in central South Georgia called Valdosta State University, and they had a spot called Grand Bay, and it was actually a field trip in the geology class. And we went out there, and you kind of go out into the middle of this swamp. Most of the Carolina Bays are really swampy. They're low-lying, swampy areas, and they usually don't have outlets, so they hold a lot of water right there. And on this field trip, we went out to the middle, and there's like a 100-foot tower, and you can climb all the way up to the top of the tower, and just see this huge, I thought it was circular, but this huge circular swamp all the way around you. And I remember asking my professor, I was like, it's really cool, but how did this form? Like, how did it become so circular like this? And even back in, I think it was the year 2000, he said that, he's like, they're called Carolina Bays. He told me they were called Carolina Bays, and that it was a pond, and the wind shaped them into that direction. He did say, though, back in the year 2000, that there are some people that think that there was a cosmic impact that created them, or that they may have been formed from a catastrophic, but he waved that off pretty quick. It was like, but that's not what we're going to go with the wind and water.
Yeah.
So so I was fascinated then. That's actually how I first came across George Howard stuff, was researching that back in the year 2000. That's before we even had Google, I think.
Yeah.
I think I was asking Jeeves, like, what Carolina Bays? Jeeves, tell me. And it actually brought up George's website, George Howard, who we all know. It brought up his website, and
Yeah, we had him on the podcast. He was our first episode, and he said that he actually has georgehoward.com, and he put the Carolina Bays stuff on georgehoward.com.
Yeah,
He said for years his site just had the SEO of returning Carolina Bays stuff because that was georgehoward.com.
Yep. And, not to retell his story, but, it was 15 years prior to that he was first introduced to Carolina Bays himself, right? He was working at the Senate, and the senator he was working for lived in North Carolina and wanted, some topographic maps, because that's what we had back then. We had topo maps. And George was like, what are these elliptical things all over your property? And that's when he says, the old North Carolina senator, they're meteor holes.
There's ellipses all over the map. He said, meteor holes.
And he tells a whole story about how, he was, back in the 30s when he was a boy, they had this meteor, or they they first discovered them, and they credited them to meteors impacting the ground. But like I said, that was because they had aerial photos back then. Even in the year 2000, we were still using aerial photos. We didn't have Google Earth or anything yet. And I can remember making mosaics by printing out, 8 by 11 sheets of paper and, of an area, and then pasting them all together to get a big mosaic. And actually, while I was at school is when I started rolling out the GIS labs, the Geographic Information Systems, and they started to, that became much more popular right after I graduated, of course. So I didn't get to use it. But
So what makes these so interesting? Why are they such a unique geological formation?
well, I think it's the ellipticity of them, like how elliptical that they are, because they, like I said, that's not something that you normally find in nature. They, in Florida, even close to where I was at in Valdosta, we had sinkholes, and that's what I was kind of aiming at. I was like, this must be like a huge sinkhole underneath this thing, and it's kind of filled in over time. And that's when the professor was like, no, actually, this is something completely different. And come to find out, like I said, you start getting into the Carolinas, and it's just covers the terrain, like all the way across the Carolinas, all the way up to pretty much to New York. So, and then as I was getting at a minute ago, more recently, about, I want to say it's about 25 years ago, they found that the Nebraska rainwater basins have like the same identical elliptical shapes and orientation, just in the opposite direction. So they actually all point to one spot over Michigan, which is fascinating.
So these are ovular in shape,
Right.
and then as you go up the coast, they kind of turn.
Mhm.
And then over in Nebraska, they also are facing the other direction to where all of the ovals are pointing
Yep.
directly over Michigan.
Yep.
And it's a grand scale.
Yeah, it's like I said, whatever happened was huge, but the currently academic, and I say the currently academic accepted hypothesis because they're all still hypotheses. We don't know. Like, this is a true mystery, which is kind of cool, right? Because we're all in the mystery machine. Like, we're all trying to solve it right now. And so even the academic side, they're always going to focus on a gradualistic explanation for pretty much anything geological, right? And that's what they're looking at the Carolina Bays. And then you've got like catastrophism, which is like sometimes things happen really quick. And that's what I think these Carolina Bays and the Nebraska rainwater basins are an effect of, like an impact over an ice sheet over Michigan. And at some time in the past. And that's something that's, another whole different debate on when it could have happened. But yeah, I think that there was a huge impact. And you actually started this discussion talking about the Chicxulub, the one in the Yucatan that took out the dinosaurs. I tend to lean in the direction that it was a very similar event. The biggest difference was, instead of this thing hitting a shallow sea and causing, tsunamis and ash to block out the sun for months at a time, that this hit an ice sheet, which is much more forgiving. And we ended up with these Carolina Bays everywhere. And we're finding now evidence that there was a lot of side effects of this impact too. So no matter when it happened, like I said, right now there's a couple different time frames we can look at, but it would have been a major, major deal. And I think the ice actually saved us. I think it.
Yeah, because it would have hit an ice sheet that would have been about how thick?
Depending on when it happened, we know that one of the time frames is the Younger Dryas, and that's the most popular, direction.
And that's like 12,000 years ago.
Yeah, 12,900 years ago, because we are finding a lot of evidence right now of an impact happening at that time. The Younger Dryas boundary is there's been a lot of research into the black mat layer and the platinum that they're finding there and the micro diamonds, and so something happened 12,860 years ago in July or what.
When you say the Younger Dryas, how'd you say it? Stratum or level layer? You said?
The black. There is a black mat layer that they found. So, and I'm pretty sure George talked about this in your podcast as well. The big hack that they did, the Comet Research Group did, who were the main investigators into an impact happening at the end of the last ice age, which is the Younger Dryas time frame. They went to Clovis sites, known Clovis sites that
of the Clovis people.
The Clovis people, yeah,
Okay.
because their culture pretty much collapsed at the same time. Again, the same time that we're finding all of this proxy evidence too, right? The big mega mammals went extinct at this time. All here where we're filming the podcast in my bunker down here. We would have had ground sloths. We would have had a couple different types of elephant species. They had the woolly mammoths and the mastodons. They were all right here. We had mastodons, and we had the glyptodons, the huge armadillos wandering around down here. The saber-toothed cats. There's all kinds of stuff that were here, and they're all gone. They all went extinct during that time frame. That Younger Dryas time frame. So something major happened, right? And so there are some people that think that the event would have been so large that it could be the same event that created these Carolina Bays if they were created by an impact.
And it sounds like this debate's been raging since the 30s amongst geologists. Is this one of the big mysteries in like North American geology?
I would think so. Yeah, I think so for sure. And the biggest, it's almost comical how little attention it's gotten, right?
Yeah.
Because they are so, we'll look at some pictures in a minute, but how many that there are all across the eastern United States. If this is caused by an impact, this would have been a huge deal. It would have been a big deal.
What I find so interesting is how they're all directionally facing the same destination point, or at least the origination point. And then the fact that they discovered more in Nebraska that also, so on the other side, you can imagine one blasts in all directions over to the left, to the west towards Nebraska, and the east towards that. And all of the ovals point in the exact same direction.
Right, yeah. I use the analogy that they're like a whole classroom full of third graders, and you get caught doing something bad. They're like, ooh, it was him. And they're all pointing right at the problem source, right? They're all pointing right at Michigan, literally at Michigan. And where they're pointing, there is a huge depression. There's a huge geologic depression, or a basin. The Michigan Basin is right where they're all pointing. And like I said, we'll look at some pictures in a minute. It's like a bullseye. There literally is a bullseye.
Is it near Mackinac Island? Is it close to there?
No. The Michigan Basin is pretty much the entire state of Michigan.
No way.
Yeah, like inside the Great Lakes, that whole the what do they call it, the mitten?
Yeah.
It was almost acted like a catcher's mitt. Because I think the ice sheet right on top of that got hammered.
And so as I understand it, basically if a meteor hits the ground, it creates microtubules, nanodiamonds, all of these things like the black mat that you're talking about that are only created generally from a meteor impact, maybe some lightning.
Yeah,
or
right now
like
though, the Comet Research Group, they haven't found any craters yet, right?
Right.
Now, if they hit the ice sheet, then again, I think that we would have something. And we don't have enough science right now to cross that off the list. Because when have we ever studied an impact into an ice sheet? We haven't. There was one that happened on Mars, and we have like video, or not video. We have picture evidence of it. We don't have enough science behind glacial impacts. We don't.
It reminds me of like an airbag, or like a stuntman jumping out of a building, and instead of falling on the ground and making a huge indent, he hits the airbag, and it
not only that, but
him, then sprays all the air out. But this is a huge glacier.
And so imagine like there being loose ice on that spray, and it just being launched into the air. That's what we're talking about.
Well, like the size of icebergs almost.
These would have been huge.
Icebergs flying through the sky, hitting Nebraska, basically.
Yeah, if the science is accurate, some of the ejected ice could have been the size of like stadiums, like wow. Huge, like really, really large chunks of ice leaving Michigan, going up into the atmosphere. Now there's some debate. I actually recently was talking with a guy who has a PhD in physics, and he is adamant. He has actually on board with everything we've said about Carolina Bays, with the exception of how they form perfect ellipses. And he thinks that as they came back into the atmosphere, that the physics doesn't support them being solid when they hit the ground, that they would have burst before they hit the ground. And it's actually the shockwave of the airburst that created the elliptical shapes. If he could back it up with science, I'm all about listening and and changing. And I'm not out to like get anybody or anything like that. I've been following the science for a long time. And if it takes me in another direction, I'm okay with doing that. So airburst could be a conclusion for that too. So we'll see. But like I said, that's new.
So when do you think this happened?
So for a long time, I did think the Younger Dryas, because that's been a sexy topic. You know, you guys have both heard about the Younger Dryas. You know what it means now. A lot of people still don't. A lot of people still have no clue that at the end of our last ice age, as we were coming out of the ice age, that we got rocked back into it for 1,200 years. A lot of people have no clue that we did that. And again, we don't even have enough evidence and science to back that it was this event that knocked out all of those, mega mammoths and stuff. Because just recently they were blaming us, right? And just recently they were blaming the Clovis people, and they also pretty much went extinct, right? Their culture just disappeared then. So for a long time, I looked at that and I was like, that makes a lot of sense. And there is a guy, Antonio Zamora. He was at the Cosmic Summit with me this past June. And we shared the stage together, so that was kind of cool. I was totally on board with his hypothesis that the Carolina Bays were Younger Dryas in age, and that's what knocked out all of these mega mammals, and that's what caused the collapse of the Clovis culture, and that's where all of this proxy evidence came from, and things like that. But then I literally, for a couple of years, my whole YouTube channel was based on that, for a while, and I had an argument with another researcher in the Carolina Bays one night. His name's Michael Davies. He's actually the one who has provided us with the LiDAR images that you can use with Google Earth now. So you can actually pull up Google Earth and LiDAR at the same time. It's freaking phenomenal. It's awesome. Yeah. But he thinks that they were much older, and he also thinks that they were created by this cavitated ejected regolith blanket, and he's got a whole. It's very complex, and I feel like the more complex we get, that kind of takes it away from where we should be looking.
It's not Occam's razor.
Yeah, well, it could, it could be.
Yeah.
It could be the simplest. That something punched a hole in the ice and it sent ice away. That's to me, that's Occam's razor. In action when we're looking at that. But he says he thinks that they're much older.
Like how much older? Because right now, 12,500 years ago versus
around 800,000 years.
800,000.
Yeah, 786,000 years ago. So what we're looking at is a Younger Dryas or possibly a mid-Pleistocene transition time frame. Mid-Pleistocene. So the Pleistocene was the age that we were in during the Ice Age, right? So as we came out of the last Ice Age is when we entered the Holocene. And
what years would the Pleistocene have been?
3 million years to 12,600 years ago, or 800 years ago. And I can't remember if it's I should know this, but I can't remember if it's the beginning of the Younger Dryas or the end of it, where the Holocene
11,500 to 12,000.
11,600.
Yeah.
I want to say it's the end, because we did get rocked back into the Ice Age, and then we came out, and I think that's when the Holocene started. I've got a graph somewhere in there that shows it, but so the age before that was the Pleistocene. That was really the time when all the big mammals were really doing their thing. The mastodons and mammoths and all that were really thriving throughout the Pleistocene. But in the middle of it, there was another big hiccup, and there's actually a couple researchers that are on, been doing a lot of research on this. Michael Davies is one. The other one is Tim Harris, who I might talk about a little bit later. But it was actually the tectites, the AA tectites.
What's that?
They're Australasian tectites. A tectite is like a meteorite, but it came from Earth. So it's like melted glass that was ejected from an impact site. We have actually some in Georgia, just not far from here.
So a meteor hits the Earth, and then some of the dirt that's already on the Earth or whatever melts into glass.
Yeah. It hits. The energy is so violent. Yeah, it's so violent that it launches the molten ejecta into the atmosphere. As it's coming back in, it resolidifies and then comes crashing back down. You basically have glass falling onto the Earth.
So a meteorite is the actual rock that's falling down. That's a piece of the rock of the meteor.
Mm-hmm.
And then the spray of the dirt from the meteor impact creates a tectite if it liquefies.
Yeah, pretty much.
Yeah. Okay.
Yeah. Anyway, so there's a tectite field all the way on the other side of the planet, like in Australia, the ocean between Australia and Laos and Thailand and that whole area. The I can't remember the country there, but
Indonesia, kind of.
Yeah, the whole Indonesia. They find these black tectites that are everywhere. I actually have a couple of them over there. We can look at them in a minute, but
Cool.
they don't know where they came from, and so this whole tectite field is huge, and that's a mystery. We don't know where they came from. There are some scientists that think that it happened actually in Laos, I think, and that the whole area got covered up in lava, and so they're like, oh, the evidence is gone now. We don't have it, but this guy Tim Harris, who used to work for Lockheed Martin and Boeing, and he's a mechanical engineer, and he's like, I've done all the physics behind this, and these suckers came from Michigan. He's like, they came from Michigan, which is the actual pretty interesting because it's the antipod of Michigan. Like where we find most of these tectites is literally on the opposite side of the world. So if something dotted it here, everything comes back around on the inside of the other side. Yeah. And so that's where we find all these tectites. And so I was like, that's pretty interesting, And so we know for sure that there was a major impact 786,000 years ago that we don't know where it happened. Like we just don't know. We know where the dinosaur killer hit, right? It hit in the Chicxulub, the Yucatan, yeah.
How do we know it was 700,000 years ago?
It's where they find it in the strata.
Oh, as they count the layers down, they find it there.
Yeah, and they found other ways too. They can. There's another way to date it.
Okay.
It's using the radioisotopes and things like that.
Okay.
They can figure it out. Yeah. Because it was created. The molten magma was solidified during that time. So, but anyways, so yeah, they found he links it to that. He's got a really good, solid background to support it, and
But that's just a theory about when the tectites came into formation.
Yeah.
Is that separate from the Carolina Bays?
Well, okay, so they're tying the two together. They think that this impact happened. That's where Saginaw Bay comes in. You may have heard of Saginaw Bay. They think that's the crater was Saginaw Bay. It hit the ice above Saginaw Bay. The Saginaw Bay, which it might show the directionality of the impact. And that the missing portion of Saginaw Bay is where these tectites came from. And then the ice. Their hypothesis is that the ice and the pulverized sandstone, which is what the Michigan basin is made up of, it's all sandstones, layers of sandstone, that washed over. And so we actually do have some pretty crazy layers of sand across the United States that they're undated. They can't date them. They're like, where did this huge section of sand come from? It's just completely sterile. There's nothing alive in it. No way to date it at all. And so they're like, ooh, where did that come from? So there might be some truth to what they're saying there too, but they also think that the Carolina Bays formed as this ejected blanket had air pockets, and the pockets were popping. But again, we're talking like a couple mile wide bubble popping, and I'm like, I don't know if you would have like perfect elliptical shapes. I could be wrong, but I think that you would have different shapes. And
you were telling us over dinner these are perfect shaped.
Yeah, that's we actually just Antonio Zamora and I just published a paper. In June. It's on the June edition of the Journal of the Journal of Environmental and Earth Sciences, the June edition of that. And we basically are proving that these Carolina Bays are perfectly elliptical by using the least squared method. Where we're going around and you have to mark all the way around the Carolina Bay and then fit it to using the least squares method to show that it's, and we also prove it by looking at the error, the percent error of it. And so anything under 3% we consider darn near perfect.
Yeah, not natural.
Because I mean, again, there's going to be erosion. There's going to be all kinds of things that can change a shape. But if it's under 3%, that thing is pretty near. And we're finding them like one after another.
What percentage of them are under 3%?
I mean, they all haven't been,
that you've surveyed.
Yeah, I mean, like I said, we can look at images and just see, like, you could just see that they're all like perfectly elliptical.
How many Carolina Bays are there?
There right now, Michael Davies he's actually, I mentioned him. He's they used to be called the Carolina Bay Survey. He has changed it to the Ovoid Basin Survey because he started to include a couple other, I call them pseudo Carolina Bays. They're not actual. I don't think they're part of this story, but there's elliptical. They're not elliptical. There's some roundish shaped or ovoid shaped depressions in Texas that are actually playa lakes and things like that. So, but I think he's marked around over 70,000 of them, which is pretty darn impressive. Yeah, that's pretty impressive. Now, if you go down to Wikipedia, they say there's like 500,000 of them, I don't think it's accurate. The Wikipedia page for Carolina Bays is terrible. It's awful. It's really bad. And like I said, even just the numbers are off. And it would actually support us to say there was 500,000 of them, but we're like, no, if we're gonna do it, guys, let's do it right.
Yeah.
So he's marked at least 70,000 of these things, and I think he's marked over 70, almost 80,000 total. But like I said, a portion of that are other ovoid structures.
Are there a lot of them in Canada as well?
No, and that's Canada was covered with the ice sheet, so we don't have any of those in Canada. Now, if you get up to very northern Canada around the Arctic Circle, that's where you come into some of those oriented lakes that often get confused with Carolina Bays, even from people that should know better, like from academic geologists, which I've had discussions with that should know better, that they're not the same thing. But they up there they have permafrost, they have and that's what those oriented lakes are. Every year the ground is completely frozen throughout the whole year, permafrost. And during the summer months, they thaw out. And so you do have ponds, and you do have directional winds coming right from the ocean that's right next to it, right? And so they're like, well, they're the same thing. We have them up there. Look at these Carolina Bays. Well, there was never, in the last ice age, never permafrost anywhere near them. So that right there just crosses that off the list. And like I said, they'll still argue with you that that's what they are, but they're not. There's no way. Like I said, I call those pseudo Carolina Bays.
Do these exist anywhere else in the world?
No, not with that.
This is unique geological formation.
Mm-hmm. Yeah, as far as I've been able to tell so far, like I said, people come up with like, well, what about these? But I can show them that like, no, those are playa lakes, which is, where you have usually it's in a river valley, and the river will flood. And as the water's running over, it'll cause like water to swirl and create this, but they're never even close to being, the percent error using the least squares, but they're never close.
Does mainstream academia recognize these as something from the impact over Michigan? And maybe we're all just arguing over the timeline of when that happened?
No, like I said, mainstream academia is totally fine with saying that they are gradual wind and water features.
Why?
Yeah. I don't know.
Is there any is there any evidence to back that up you think is at least as strong as this? The fact that they all point to Michigan is so interesting.
It is interesting, yeah. And we also have to keep in mind though that when there was a 2 miles of ice, on top of Michigan, that they did have something. It's called katabatic winds. That's the air is really cold over a glacier, and it comes rushing off the glacier. And so that's the directional winds that they're using. They're using the katabatic winds coming off the Laurentide ice sheet. And now again, they have to, for their hypothesis to be true, every Carolina Bay had to have been a pond during that time long enough for it to swirl it into an ellipse, right?
70,000 ponds.
Yeah, 70,000 ponds.
All perfectly swirled into ellipses
again,
all perfectly aim at Michigan.
Yeah.
And they acknowledged that there was this 2 miles thick of ice over Michigan. That's not that's not in contestation.
No. That's We all agree that the ice age produced huge sheet glaciers over all of Canada. I mean,
what's going on? Why? What is who decides what mainstream is in geology?
I don't know. I don't know if it's degrees, and it's probably the same with everything too. As you're going through college and you have your professors, and I see it right now when I'm having discussions with some of these academic scientists. A lot of it is, they learned from their predecessors that were, during the 70s and 80s. They didn't have access to LiDAR. They didn't have access to any of this. And, what do they say? That science changes one funeral at a time, and we just got to wait for it to catch up. And I feel like we shouldn't have to do that anymore. I feel like we have enough evidence now to support that there could have been something major, at least acknowledge that it could have happened. And then let's let science do the rest, right?
It feels like the least scientific thing you could do to not change your mind.
Yes.
Like the whole point of science is to test hypotheses, then it should be celebrated when we disprove things.
Yeah.
It should be, hey, we're moving forward. Yeah. Not, hey, I discovered something and I'm going to dig my heels in here. Even when new evidence like LiDAR and math and LLMs and AI come and help clarify some things.
Yeah, and that's probably what got me going like down this path that I'm taking right now, because it's not an easy thing. Like I said, you're literally walking into lion's den sometime and be like, I really think you guys need to re-examine a few things, and I'll show you why. And nobody wants to be told that they're wrong, and so they're like, ugh.
But they should.
Right.
Scientists should want to be told they're wrong.
And that's why I jumped in, was because that's my job. I am an academic science teacher. Like, that's what I do. I'm an educator. I just happen to teach juniors and seniors that have like no interest to be in my classroom. I have to get really creative sometimes. Yeah, I don't think that they're following the scientific method. And that's basically what you're saying, is that they're not following the scientific method. When new evidence is presented, it should cause a reinvestigation, at the very least. If it supports, if it goes back and supports your old hypothesis, fine. That's what science is. But if it's enough to change the hypothesis, then it needs to change and it needs to progress and push forward. And this thing has not changed or progressed, I could say, at least since 1977, which was the year I was born. So it's going on 48 years that this has been the dominant academic hypothesis for Carolina Bays.
Even if you're proven wrong, it doesn't mean you didn't push humanity forward. I mean, we're all standing on the shoulders of the men who came before us and are trying to discover things.
Right.
And it's okay that Newton invented calculus and we have Newtonian physics and now we have quantum physics.
Right.
No one looks back and goes, Newton, what
an idiot.
What a bozo, He didn't know about quantum. It's like, it's actually really helpful. And I think that's really, it's frustrating from the outside looking in.
Yeah. And it's odd too, because I'm one of the only people in this whole conversation that has changed their mind. Like I said, I did used to think that this was a Younger Dryas event. And I have changed my mind. I now do think that they're older. My mind might change again. I keep hoping that, like, Antonio Zamora will present better evidence to get me back in, because the Younger Dryas is a whole lot more fun, I'll be honest.
Yeah, totally.
That's why we talked about it earlier, during dinner, that, we all kind of got brought in because of that story, and the Carolina Bays brings in a lot of people because of that story. You either don't know about them or you do, and if you do know about them, you're all in it.
Well, I think it's a sign of wisdom and a sign of humility to change your mind on something.
Well,
this
sucks.
looks,
it sucks. Like,
and it sucks too.
I'll tell you what happened. I was having a discussion with Michael Davies about Carolina Bays, and he was telling me about the coastal plain, which we're at right now. In this, in my what do we call it again?
Bunker.
Yeah,
bunker,
my bunker.
yeah.
That's right.
Yeah, we're on the coastal plain. We're actually really close to sea level right here. And Michael he made a comment that the coastal plain is pool table flat, like from the Piedmont all the way down to the beach. It's like pool table flat. And I was like, Michael, it's not pool table flat. I said, we have, you guys actually on your way here went up and down. It's not super noticeable, but you went up and down over old ancient barrier islands. We have barrier islands here on the coast of Georgia. And the last time we had a coast here was 125,000 years ago, and we can actually go to that old beach. It's just elevated now. It's about 30 feet higher than everything else around us. We actually call them. It has a completely different ecology. We call them sandhills here. Got all kinds. This is usually where you're going to find most of your like diamondback rattlesnakes and your gopher tortoises, and different plants grow there, like the longleaf pine tree, and so it's just a whole different ecology, which is, that's what interests most people. But the geology of it's fascinating too, because that's, again, the barrier island from 125,000 years ago. And that may seem like a long time ago, but that was really the last time the sea level, it was the last interglacial. Like, we're in an interglacial now.
What does that mean?
Interglacial is, we have glaciation cycles, which is where we have 2 miles of ice over Canada.
It builds up.
Right, and then it melts and fills in the oceans. Sea levels rise 400 feet, right? The beach, I should say, during the peak of the glaciation, it was around 25,000 years ago. The beach would have been 100 miles farther away from here. So you drove quite a bit today. You know how long 100 miles is. That's a long ways, right?
It's a lot of water.
So to get to the beach 25,000 years ago, we would have had to get in a car and drive 100 miles further east just to get to the beach. And it's like literally like a couple miles from here. You can get to it less than a mile from here. And so 125,000 years ago was the last time sea levels were as high as they are today, right? And they were actually higher than today, which is interesting. We talked a little bit about global warming earlier, but the last time sea levels rose as at least this high, they actually rose higher, and there was nobody driving, SUVs or anything like that back then. So, what's causing the alarm today is kind of crazy. But 125,000 years ago was a little bit warmer, seas were a little bit higher, and we have a beach that formed during that time. So, anyways, I was having this conversation with Michael Davies, and I was like, "No, Michael, it's not pool table flat. We have these pool tables. Let me show you." And I pulled up his, like that's how like arrogant I am. I pulled up his LiDAR. I was like, "Look, man," and what I saw actually kind of like hit me. I was like, "Oh, okay, hold on," because when I pulled up the LiDAR to show him these barrier islands, I noticed that you only find the Carolina Bays on top of the barrier islands. Anything that was under that barrier island is gone. There's no Carolina Bays. Like, so 30 feet, about 8 meters, I guess it is. There's 10 meters. There's no Carolina Bays all the way to the beach. None. And they should be, if this event happened during the Younger Dryas, at the end of the last ice age, sea levels hadn't risen all the way up yet. They had risen up. There was still about 260 feet of elevation that hadn't happened yet. That has happened since the Younger Dryas. We should find Carolina Bays all the way to the beach, if this event happened 13,000 years ago. And there's none. There are no Carolina Bays. The only place that we do find some are in areas with well-known subsidence where the ground's actually sinking, kind of like Louisiana. Like it's below sea level now.
There's an alternative reason why it's lower. It's because the ground's sinking back down.
Right. So the Delmarva Peninsula, for instance, there are Carolina Bays under 30 feet. But you can still see the very well-defined shoreline that was created then.
Do we have any Carolina Bays that are like half there? Because
yes, I'll show you some pictures.
Oh yeah, I'd love to see those.
Yeah. So when I saw that, I was like, literally, it was like somebody punched me right in the stomach. I was like, oh man, because for years I was on that Younger Dryas train, boy, I was ready to go, and like within an instant, I was like, there's no way. There should be Carolina Bays all the way to the beach because sea levels have not risen above our current shoreline. It's been steady for around 6,000 years, and we should see a whole bunch of evidence between 30 feet and the ocean, and there's hardly any. So that's when I was like, they have to be older, at least older than the last interglacial, which was 125,000 years ago. The more I look into it, I think we see evidence of there being Carolina Bays that were eroded 400,000 years ago. So that puts it way back into and here's the thing too, and a lot of people will debate this by saying that there's no way that they could be that old. But those shorelines that we're dating, they're still here. We can still go to the beach that was here 400,000 years ago. We can go up farther and go to the beach that was here over 1 million years ago. We can go to the beach that was here 20 million years ago. So we have these different beaches, these different, I can't remember what they call them right now, but they have these different stages, these different levels of shorelines as you go inland from the beach. So
are you familiar with Randall Carlson and what he was talking about in the Pacific Northwest with the lands with all the rushing water over there?
Mm-hmm.
And do you think that relates in timelines to either the Younger Dryas, or does that match with this, or do you have an opinion on that?
Well, I mean, again,
or does that relate at all?
I don't think it does. And there's, you guys know who Nick Zentner is? He's a geologist out of Washington State. He does a lot of work on like the mega floods and things like that too. And he dates them back to like, I think 16,000 years. So it was like predates the Younger Dryas by a little bit. I don't want to get too much into that, but
okay.
Yeah, I don't know. I know that there's mega floods, and that's cool enough for me. I'm like, yeah, cool geology. Let's go. I'm not 100% sure that they are exactly Younger Dryas in age. I could be wrong, and he could be. Ask him. You guys are gonna go talk to him soon. So
yeah, we'll check in.
Well, let's go back to the vegetation. You mentioned vegetation. You said that bay trees grow in these Carolina Bays.
Yeah.
Is that like the bay leaves that we cook with?
Yeah. So most bay leaves that you're talking about are like they're grown in Italy, like they're Mediterranean, right? So the old grandmas would put bay leaves in spaghetti and stuff like that. We do have a species of bay tree here though that we put in crab boils and things like that. So it is a species of bay tree that I'm sure we have some around here that we can.
Oh,
because
they don't just grow in the Carolina Bays.
No,
they grow all over.
Now there are some neat vegetation that grow only in Carolina Bays. I shouldn't say that either because they just need really good swampy areas, and the Carolina Bays are really good swampy areas. They're the really cool carnivorous plants like the
like a Venus
flytrap. We have pitcher plants here, where they have this really neat hood that's like a flute with a hood over it, and it's usually open, and then bugs will crawl in and fall down into the water, and then the hood will close on them and they can't get out, and then they just decay because the soil there, again, it's really crappy swamp soil, really low in oxygen, and really not a lot of good organics and stuff like that in there, and so they get the nutrients that they need by trapping the bugs and then using their guts.
Has anyone proposed that these carnivorous plants flew in on a comet? And
I've heard. Well, you guys talked with Chandra Wickramasinghe?
No, not yet.
Yeah, if you should call him. Yeah, get an interview with him because he loves to talk about it. He actually did an interview with one of my honor students. I teach for an online school as well. I have actually 2 of them. But one of my honor students I hooked up with Chandra.
Oh, really?
And he did like a 45-minute interview with him. It was pretty cool.
I think that's who George Howard says is the smartest person on the planet.
He is fascinating.
Yeah.
And he's so kind. He's like one of the kindest people ever. But that's one of his hypotheses is that not necessarily connecting Carolina Bays or anything like that, but that that viruses hitch rides on comets, and there's some evidence that these viruses can alter DNA, and so the ones that come in, they alter DNA over time, and that could be what causes these plants to become, to change through evolution, and that's where the spark is that causes the change. I don't know. Like I said, I think that they just are really good swampy plants, and the Carolina Bays happen to be really good swampy places, so we find a lot of them there.
So there's no vegetation that's like specific to the Carolina Bays. What do we find?
And that's
is there
the
anything
thing too,
you find?
Yeah. So again, one of the things that the gradualistic academic hypotheses, again, they all had to have been ponds, and I think that goes back to like the early 30s because some of the first ones we see had ponds in them. But now that we have LiDAR, we can see Carolina Bays everywhere. There's some that they call them ghost Carolina Bays. Unfortunately, a lot of where we find these are really prime agricultural land. So again, it's not like they're all swampy areas. They'll be plowed up and they'll be used as farms. In fact, George Howard, Antonio Zamora, and Michael Davies and I all met up at a Carolina Bay back in 2017, maybe 2019. It was actually one that was part of his that he was working with doing the reclamation, the
swamp restoration,
ecosystem restoration.
Yeah.
And before they went in to turn it back into a swamp, because the guy had been using it as a cornfield, and he got into turkeys or something instead, and so he had this big Carolina Bay, and George's like, well, we'll buy it, and we'll turn it back into a swamp, and they actually had to go back in and do that. But before they did that, we spent a whole bunch of time digging into it and grabbing a bunch of dirt out of it and sifting through it. We're trying to find Younger Dryas.
What does that look like to do an excavation or like a dig?
I can't really say because like we did it very quick,
unofficially.
It was going back, we were just trying to get it. It's like guerrilla science, like we went in there, he brought in a backhoe, one of his operators, just like we dug these huge trenches, and then anywhere we saw like a difference in color, we started scooping out dirt, and then I sifted through all that, and we didn't really find anything. We dug 3 huge trenches, and we sent in the soil from the first trench, and it didn't come back with anything conclusive. So I have 2 more whole samples, 2 more trenches full of samples in a box, just waiting to be tested if we ever get the money to do it. It's expensive. It's like really expensive to have them tested. So
what does it cost?
It was a couple grand. It's more than I'm willing to pay. And I know George kind of fronted the bill for the first time, and since it didn't come back with anything, he was like, "Yeah, I think we're done with that." and we did try to get some funding from the Comet Research Group, and they were like, "Yeah, if you found a little bit better evidence the first go around," because we were really interested to see what we find from the center trench, because we actually dug from a northern part of the rim. We dug right in the middle of it, and then we went to the southern trench.
So
And
you basically dig down and you dig straight down and you see layers.
you see the
Hopefully,
stratigraphy. You're supposed to see really good stratigraphy, and we did not see really good stratigraphy. It was all mashed up. It was all gross, and it was very hard to find good sample layers and things like that. Most of the evidence that they're getting from Carolina Bays are from the rims. They'll actually go in. So remember we were talking about how the hack was to use clovicites. Well, there are quite a few clovicites in the rims of Carolina Bays because during the Native American occupation, that was like a perfect place to go hunting, was in a low swampy area. And they would actually camp out on these rims. They would go hunting into these Carolina Bays. And they even found the gizzard stones from like ducks and turkeys and things like that. They were confused because they kept finding these little pebbles in their, as they're going through looking for flint pieces and for making flakes and stuff like that, making the Clovis points. And they kept finding these little pebbles, and they're like, what are these? And they were throwing them out. And somebody was like, wait, they're actually gizzard stones. They're actually from inside waterfowl. This is part of the processing of waterfowl, which is interesting too. Again, when we start looking at timelines, that's evidence of a culture living on the rim of a Carolina Bay and using it during a time when one of the hypotheses says that they were formed. And so, at the time I was like, well, they could have been here. And the cabin is like, I'm not so sure now. Now that I found some other evidence, I didn't get into what kind of changed my mind. I did. It was the not finding any evidence below it, right? And so again, that pushes it back much farther for me into the mid-Pleistocene. So, that's
yeah, because I expected you to say the Clovis sites were a good place to look because if people were living on land, then that land was exposed. Therefore,
and that's what the Younger Dryas is doing. The Comet Research Group is doing to kind of prove that it was a Younger Dryas thing, because they're actually finding. I think they went to Murray Springs. There's a mammoth kill site there, and again, it was a Clovisite that's been well dated to being 13,000 years. And they went to the site. They have a black mat layer. Now, this is not a burn layer. A lot of people get confused. I think that the Younger Dryas black mat is a burned layer. That's not true. It's actually like a really danky, like algal layer. Like during the Younger Dryas, it got really cold, and everything was wet and gross, and there wasn't a lot of sunlight, and it was just really dank. And so it created this like noticeably black layer in the stratigraphy. And they actually find that's where just under that black mat is where they find a lot of their best proxy. They find their platinum and then the microdiamonds and things like that, the carbon spherules and
so all the meteoritic detritus is just below
that, and they found that the black mat actually kind of carpeted over this kill site. So they're thinking, that this whole process was like this was an active kill site whatever happened at the Younger Dryas, and it just blanketed this whole thing. And that's where they're finding their best stuff is right there underneath that black mat layer. And they don't find any evidence of Clovis culture or most of the mega mammals above the black mat, right? Everything's under it, nothing's above it. And that's really kind of telling that something major happened during the Younger Dryas. Now, right now, they're really thinking that this was a huge bolide event.
What's that?
It's a bolide is when a like a meteorite blows up in the atmosphere before it hits the ground. The last time this happened, not the last time, actually every shooting star is a miniature bolide. But the last major event was in Russia, in Chelyabinsk in 2012, I think it was. And there was a meteor about the size of a school bus that came in, and it blew up over Chelyabinsk, Russia. And the shockwave of that explosion shattered glass and injured, I think, 1,700 people. And the actual meteor did make it all the way in. It landed into a lake, and they were actually able to recover this Volkswagen-sized chunk of this bolide. Yeah, it's pretty neat.
I don't understand why meteors blow up in the air before
I think
they
it's
hit
just
the ground.
It's the heat. Yeah, the heat and the really quick change in density. Just like if you have something like really hot, in a microwave and you put it into a cold sink, it just shatters. So it's coming through. You got to keep in mind when it's out in space, it's frigid, and then it hits our atmosphere, and it gets super hot. The thermosphere, I think it can get to be like 2,000 degrees. And then as it goes from the thermosphere, that's when we see shooting stars streak across the sky. And then instantly they go into the mesosphere, where it's like negative 200, and it just shatters. They just completely. So most of them blow up in the mesosphere as they're approaching the Earth, and just it's the big ones that either the really big ones that make it all the way through, or the ones that come more directionally, like straight through the atmosphere real quick. they hit pretty good.
There's a layer of the atmosphere that's 2,000 degrees Fahrenheit.
Well, the thermosphere is like the very outer edge. It's like the
it's
like
hot?
the friction of the atmosphere is actually, yeah, it's like super hot.
Oh, I didn't
Yeah,
know that.
yeah,
I always
super hot.
picture it just getting colder as I go higher.
Well, it's really, there's like an inversion too as you go through. Like it starts to cool off, and then it warms back up, and then it cools off really cold in the mesosphere, and then the thermosphere gets really hot. So yeah, when these meteors come in, they usually get superheated. We see that streak, and then they get really cold, and most of them shatter as they come through. And there's actually a guy, I can't remember his name, but they're finding after a big a fireball is like a big shooting star, and they're going out in there. I think it's the Stardust Project or something, but they're going on top of roofs, and they're sweeping the roofs, and then they're pretty much using the same process that the Comet Research Group uses to find their proxy, but they're finding all the platinums and all that kind of stuff from shooting stars and fireballs and small bolides. So what they're thinking is that 13,000 years ago, we went through a very dense portion of the Taurid meteor stream, and instead of having like one shooting star streak across the sky and everybody's like, ooh, let's wish upon the star, there was a whole bunch of them, and they were big ones, and they were blowing up and causing a lot of, as Randall says, a lot of havoc. And and it was big. It was a big deal. Whatever happened at the end, and again, I don't want to take away just because I don't think that the Carolina Bays and the Younger Dryas are not part of the same story. I don't want to take away from the Younger Dryas, because that was a big event. I mean, it was a huge event. I just don't think that they're related. I think that this older event where we find the AA tectites, and we find the all the other proxy that's going on there. I haven't even talked about the other stuff. That we have a huge bottleneck of Homo sapien DNA. This is actually pre-Homo sapien DNA. This would have been like the what's the species that we came from? I should know this.
Oh yeah, the Magna, or
I can't remember.
I can't remember.
It's actually where Homo sapiens and the Neanderthals split from a common ancestor.
Okay.
That happened at the mid-Pleistocene.
Is that the Cro-Magnon example they found?
Yeah, it's not what I'm thinking of, but I think I was thinking of like Lucy or something. But
yeah.
But I think that dates back to somewhere around there. But anyways, this is where we see a huge split in DNA from the Homo sapiens and the Neanderthals.
And this is how long ago? How many years ago?
This is around 800,000 years ago.
800,000 years ago.
Right. Which is, again, when these AA tectites were formed, and there's other evidence that supports that as well. So I just, like I said, I don't want to take away from the Younger Dryas, but I think there was a much bigger event that happened 786,000 years ago that formed the AA tectites, and I think they formed the Carolina Bays at the same time now. And again, I think the shorelines of the East Coast support that as evidence. So,
well, I can see why it's less sexy to say that, because I think the reason most people like the Younger Dryas idea is because when Plato wrote about the Atlantis Empire ending 12,000 years ago, people like to say, oh, okay, now we see the Younger Dryas impact, and that probably killed the Atlanteans.
Right.
And so it ties up all sorts of mysteries that we all wonder about on YouTube.
Yeah. And that's absolutely true, and so, it's a lot of fun.
Yeah, it's a lot of fun.
That's right.
But you're forming a new narrative now. You're saying that there's something to look at closer to 800,000
years ago. Yeah, there was a huge benthic organism, benthic foraminifera extinction that happened at that time, which is a big deal. These benthic foraminifera, like microscopic organisms that live on the bottom of the ocean. I mean, how bad does that have to be for like those suckers to die? Like those things like survive anything. And there was a huge mass extinction event of those at the same time. And again, we're just now figuring out what happened. Well, we haven't figured it out. We're still like debating and trying to come up with better evidence of what happened 13,000 years ago. As you said, during the time where we were well established, and I say that, but our own history is so jacked up. Like we literally say that, and I feel bad because this is part of like what I teach when we're talking about I used to. I don't anymore. It's a pretty interesting topic in my classroom, by the way.
Yeah.
I can
When we talk
imagine.
about the agricultural revolution, that we came out of the ice age, we were all hunters and gatherers, and then it's like 12,000 years ago or 10,000 years ago, we were like, oh wait, guys, we can grow seeds around our huts, and we can start, you know, raising goats and pigs and stuff around us, and we start agriculture, and all of a sudden we become civilized, and and then now we have the industrial revolution going on, and it's there's so much history before that
Yeah.
Yeah. What
that
do
we
you,
don't know. And it's part of this story too, because like I said, just 20,000 years ago, sea levels were 100 miles farther away. And that's where we're going to find our stuff. That's where we're going to find, 400 feet in the ocean, which, I mean, even scuba diving, like you can only safely go down around 100 feet.
right.
And that's dangerous, right? That can kill you going down 100 feet.
Totally.
And we're talking about 300 feet below that, 400 feet from the surface down. That's where this ocean was at the peak of the last ice age, and humans were here. We've been around in our current form for at least what 300,000-400,000 years. And like I said, I think something major happened.
Yeah, before that, you're saying.
Yeah.
Before that.
So, and that's where we're going to find the evidence of our lost cultures. And I don't want to say like advanced civilizations, but there were people, and I think we were doing well, multiple times, and just the evidence is it's under the oceans, it's down there.
What do you think about Göbekli Tepe and how that was discovered over in Turkey, right? And then it dates back to 13,000
Yeah,
years.
I mean,
I mean, it seems to push back the whole hunter-gatherer
yeah.
narrative.
Well, and I think what they're finding now is like they were mostly still eating, protein from animals and stuff like that. So, I think they were just saying that the narrative is that they didn't have time to do that kind of stuff, right? Like they were always hunting and gathering. They're like, they're probably doing pretty darn well if they're doing this, and hunting and gathering. I can imagine if we had, mammoths to snack on all the time,
Yeah.
Yeah, it shows division of labor.
Yeah.
It shows that we had enough
Yeah,
resources
yeah.
and time to
Mhm.
build major temples
Mhm.
and then also have enough food. And so
Yeah.
that just denotes at least some sort of
Specialization.
specialization in society. It
Yeah.
shows a civil society
Mhm.
much more so than just hand to mouth hunter
Yeah.
gatherer.
And there's so much there too that we haven't even started looking at. There's, I think it's like 10% has been dug.
Yeah,
There's
and,
like so much more. There's so much to learn there. Oh my
Yeah.
God.
and they won't allow
Yeah.
it, right? The
Yeah, it's
Turkish
crazy.
government's
That's crazy.
saying no.
Well,
Yeah.
so this is really interesting that you might be sort of suggesting that we dislodge the Carolina Bays from the Younger Dryas impact, or from the Younger Dryas period, because it's no longer an impact necessarily.
Right. And again, I don't want to take away from the Younger Dryas. Like I
Right.
said, I just want to make it, known that I don't think they're part of the same event. I think
You
we're
think they
talking
both
about,
happened?
I think they both happened.
Yeah.
And by separating the two, because I think what's happening is, at least me coming at it from a Carolina Bay perspective, there's a lot of the Comet Research Group members, directly Comet Research Group researchers, that are very adamant that the Carolina Bays are not part of that story, and then they're kind of ugly about it. Like they have gotten really kind of rude about the Carolina Bays being brought up, and every time, and I understand that now. Like I said, I'm like I agree with you. I don't think they're part of the same event. But I still think there were impacts. I think they were still, the result of an impact. We're just looking at two different things. They just don't want any part of Carolina Bays, and so they're totally fine with saying, "Oh, it's wind and water. Just shut up, boy. Go away." This is
They're all pointing at Michigan.
Yeah,
I
the
don't.
splatter
right,
patterns.
right. And again, I think the ellipticity of them is the key, because even
What
in
else
like
do you
Florida, where we have sinkholes, if you have two perfectly circular sinkholes side by side, that would be really cool. Like they name them like Twin Lakes and all kinds of stuff. That's a really neat thing. And these Carolina Bays, there's just so many of them that are identically shaped. And as you said, not only are they, I mean, that's like strike one. Strike two is that they're all identically shaped. They're all pointed to the same location. And I think strike three is when you get to that location, it's literally a ringed bullseye of where they all hit. You want to look at some pictures?
Yeah.
Let's take a look
I'd
at some
love to.
pictures. I'll kind of just kind of go through this presentation really quick. Like I said, I put this presentation together just so that you guys had something to look at.
Oh yeah, and the LiDAR is so cool.
Yeah, it is cool. I mean, just look at that. Yeah. So, I mentioned before, as a science educator, I'm not seeing the scientific method being followed with this whole thing. And that's kind of what brought me into this. And that's what this slide is all about, that we're all really, if you do the scientific method, you're a scientist. And a lot of the people that are researchers in the Carolina Bays may not be a geologist. So they name, I think I'm like one of the only ones that actually has credentials in geoscience, to talk about this kind of stuff. But yeah, following that scientific method, I think is really important.
It's so strange that it's like a fringe mystery in geology.
It is.
It's just when you think of geology, I just think of people who dig in dirt and figure stuff out, and it's like, oh, and they write the history books.
Yeah.
I don't think of there being these.
And I think why is because a lot of geologists, that's what they're doing. They're digging in dirt, right? You got your trowel and you got your, your buckets and stuff like that. But you really need to have an overview of the whole thing. You need to step back and you need to have like a generalist view of different things, climatology. And that's actually what my degree was in. My master's degree was in geoscience. So I took master's level classes in oceanography and climatology and geology, meteorology, all that stuff together. And it all ties into these stories that we're talking about, right? It's all part of this Younger Dryas event, the mid-Pleistocene transition event, the Carolina Bays. You need to have a little bit of everything. But the researchers get so funneled and focused on one thing or another, and they don't see the big picture. But here's a pic. This is what the first picture, and again, it's a mosaic of hundreds of pictures taken from airplanes back in the 1930s.
And how deep are those? A couple feet?
Yeah, they're not. The rims are maybe. I mean, it's maybe 3 feet.
Okay,
Like 3 feet. Some of them get bigger, but they're super flat in the middle. We'll look at some of these. Again, we're looking at a difference between terrestrial and catastrophism, as far as explanations. And we know that's the thing too, is like, we know that things happen suddenly.
Yeah, why are geologists? It sounds like you're saying that generally they try to go with uniformitarianism,
and this goes,
but in rare exception they go to catastrophism. Why is that the case?
I really think it goes back to like over the past couple hundred years with Darwin and all that stuff. Because remember, Darwin actually started. Wasn't he a geologist first? He did a lot of geology stuff first, before he started getting into the biology. But yeah, and
So it's almost like Darwinism is this. It's a gradual process.
Well, there's been a debate back and forth between like Darwinism and
sort of Christian. Yeah,
right.
And Christian has the 6 days instant formation.
Right,
that's almost like catastrophism.
Right. Yeah, in the flood and all that kind of stuff. Right. It's always like catastrophism. And so for a long time, for hundreds of years, the uniformitarianism model, which is a geologic law. Uniformitarianism is a geologic principle. Like things happen very slowly over millions of years. One gust of wind and one grain of sand at a time. That's how geology changes. That's a principle of geology. There are other principles of geology too, that are, things like the law of lateral continuity and the law of horizontal. I can't remember it now, but we have these principles that are how geologists are supposed to study geology. And I really have a problem with uniformitarianism because we know that things happen really quickly sometimes.
It's ridiculous that it's so obvious it's both.
Yeah.
It's so obvious that things happen slowly and then comets come in and hit something and smash or volcanoes go like.
Yeah, it sounds like it just doesn't account for the torrid meteor stream, like uniform.
It's just, it's why does it have to be one or the other?
Right.
It's so obviously both.
I agree.
And I've heard the term punctuated uniformitarianism because we also know, like you said, it's both. I think it's actually a good term though, that we do have the slow processes of geology that happen over long periods of time. But you're right. We need to acknowledge that sometimes the earth gets punched in the mouth.
Yeah.
and it may happen more often than we want to admit. And we need to be keeping our eyes open for that kind of stuff. And that's what this is all about, really, right? Looking at the past to predict the future and to prepare for anything that might happen. These are all just a list of things that have in the past been hypothesized. So this is, like you said, it's a debate that's been going on since the 1930s.
Okay.
You go back into papers and look at the bibliographies, and it's just back and forth. Actually, in the paper that I just published, we have a I can't remember what it's called. It's like a graph that just kind of shows the different papers of just going back and forth, back and forth.
I love number 12.
Annotated bibliography. What's that?
I love number 12 and 13.
Yeah, actually, the giant beaver ponds is kind of a neat idea. And the guy who came up with this, he's still with us, and he's from the University of Georgia. And I think George may have talked about him on your show, but he used to be the UGA librarian, and he had extra time. He was like, Carolina Bays are cool.
Yeah,
I remember George saying that.
Yeah. So, what he thinks happened was that these beaver ponds, you got this big pond of water,
and these are big beavers.
Yeah, but he's actually like a catastrophist. He actually thinks that the event that happened at the Younger Dryas was so hot that it introduced so much energy that it flash boiled these beaver ponds, and that's what Carolina Bays are. Is the flash boiling of these beaver ponds. So it's kind of a neat hypothesis when you start looking into it. But still, I think that's a little far fetched.
Yeah, well, it does seem strange that they're flat in the middle. That to me is just
it does
very strange.
Yeah, and that's where I mentioned earlier that the guy who's been contacting me about the airburst, introducing an airburst hypothesis to this. He's like, that's the only way that could really happen. He said if the Earth was getting punched by huge chunks of ice, that we would have different shapes. Like it would not make a perfect ellipse. That it's the actual and I can see some value in that. And so I'm like, well, we'll talk, dude. Let's get
that does kind of make sense.
Yeah. So again, the importance of LiDAR, really important. This is actually in the Myrtle Beach area. This is the same location. This is the first picture back in the 30s. That's what we have today using Google Earth, which is a huge advancement in technology, to be honest.
Yep.
Which is fairly recent. We've only had it for about
decade
and a half, maybe.
Yeah.
And now, like I said, Michael Davis has been able to introduce USGS LiDAR maps, all the way down to it's like half a meter elevations and things, and he has them color coded too.
So these were taken with a satellite, I guess, of the whole Earth?
They actually, LiDAR comes from airplanes. They actually mount a LiDAR sensor underneath an airplane.
Oh, you have a picture right
there.
And
it shoots lasers down and it bounces back up. And it's like radar, but with the lasers. And so they can map. But what's really cool about it is the lasers go through the leaves of plants and things like that. So it literally is picking up the ground. And so you can remove all of the, surface distraction, really. So here's an image of Tatum, South Carolina. You didn't drive through this today, but it was probably not. You probably passed thousands of Carolina Bays coming down from North Carolina for sure.
Yeah.
Once you hit 95, you're passing a bunch of them. Did you go past the south of the border?
Oh yeah.
Yeah, there's like a dozen of them right there, right as you're driving through that little area. Yeah.
But you can't see them from the ground, right?
They're very difficult to see. I've been looking at them so long. I'm looking. I'm like, it drives my wife nuts. Going like, Carolina Bay. But yeah, again, and a lot of these are so big that you may only see the rim, like part of the rim, as you drive up and then back down. You're going over a rim, and then you do it again, and it's pretty neat. But so this is a really neat picture because you can see all the farms, you can see the highways. There's actually a town up here. That's Tatum right there. But that LiDAR really picks up those Carolina Bays in this area, and so we have all of these elliptical shaped depressions. Not only are they elliptical shaped, not only do they have that orientation, but they also overlap in some places.
Oh yeah.
That's crazy looking.
How, if this is wind and water, again, how could all of these have been ponds long enough for the waters to swirl around to make perfect ellipses? It's a ridiculous hypothesis, to be honest. That's my take on it.
Yeah.
That
it does look like
ridiculous.
Splashing water at the beach and it just splatters on the sand.
That's actually like one of my final slides on this presentation is
it's totally what it looks
a picture
like.
from the beach where I kicked water. They're all perfectly I might have to fast forward to show you.
Yeah, it does. Yeah, we can jump around.
How many of these tiny little circles are Carolina Bays too? Because some of them look way smaller, but
there's a whole bunch of them that are like look at all these up here,
like
that little
50
one.
or 60 in this photo.
Yeah, there's a whole bunch of them. You got some big ones here, and they kind of distract you from all of these little ones that are all over the place too. They're all the exact same shape. We can use methods to prove that they're identical in shape. The orientation for these are all identical. There are some variations. There are some that are a little bit off and a little bit, but you would expect that if it was something that happens catastrophically really fast.
And the color coding shows us depth, right? As
It
far as
shows us-
elevation. So all
right.
those blue ones on the left are all the exact same sort of height above sea level,
Mhm.
and the red ones in the middle are all at a different height.
Yeah. He uses Michael Davis uses a 10-meter color palette, and so if we'll see some examples in a minute, I'll explain it now. But there's some where blue is the ocean, like it starts at the ocean,
Okay.
and then you'll go up, and some places it'll go back down, and then it'll go back up. So you got to be careful sometimes and understand the terrain of the area that you're looking at
Mhm.
to understand if you're going up or down, which confuses a lot of people. A lot of people see these colors and it distracts them, and they're a little. I can't look at these without them. Otherwise, it's just all gray. It's all grayscale,
Yep.
and it sucks.
Yeah.
Yeah, way
it's
harder.
still neat. You can still see the Carolina Bays, but this is all it's color coded, and like you said, the elevation. So that whole rim, is pretty much all the same elevation, and you could really see how flat it is on the
Yep.
inside because there's no change in elevation.
In color.
Yeah,
Yeah.
and that really helps detect that. You can actually see right here where this person had. I think they dug this out to make
It's like
it
a
flat.
farm or something.
Yeah,
or
it's a farm
road.
there, right?
Yeah.
You can see it. Like if I go back, well, I guess you can't really see it very well there, but that's what it looks like. And then you see all those elliptical shaped, and you won't see, if you were driving through this area,
Wouldn't
you're
notice.
driving on this highway right here, you wouldn't notice any of it.
That's right.
Yeah, I
You
can
wouldn't
see
notice
why
any
you
of it.
keep touting the LiDAR so much. It really
Right.
changes the game
What a
when you're
step
looking at
up
this.
in seeing things from above.
Right. And we got a lot. So this is Nebraska. Again, I wanted to make it very clear that we're talking about more than likely an impact event taking place. But here's Nebraska, and super flat all the way through this area. It's all farmland. But again, when you flip over that LiDAR, you start seeing
And
all
it's
these
pointing to the
elliptical
east.
shaped
And they're pointing from the
depressions.
lower left to the upper right to the
That's
northeast.
right. Yeah.
And the other one was South Carolina, so it's the lower right to the southeast to the northwest.
Right.
So they're all pointing to Michigan.
Yep. So this is a picture. I use this picture a lot because it tells the whole story. But here's our Carolina Bays. Again, this is from another spot too. It's not like I'm picking the same spot. You can go anywhere
Yeah,
and
70,000
find
of
these.
them.
Yeah. And so these are all pointing here. This is a picture showing, pretty much the whole eastern part of the U.S., like from the Rockies over. And you can see all of these dots. This is actually an old picture because we've actually found some inside of this band right here in places like in Kansas, and there's some in like the very northeastern part of Texas.
Oh, so you're almost getting the whole circumference.
You're almost getting the whole thing. Yeah. There's
In
a
a
couple.
way.
There's not very many of them, and a lot of it has to do with erosion and ground type. But if you know what you're looking for and you have access to that LiDAR, I mean, I can't tell you how many hours I've scanned like LiDAR and be like, wait, found one.
You can almost have machine learning start to find it if you could draw that circumference. You could
Yeah.
almost throw them in and let an LLM.
I
pick
think
'em up.
I think that's I don't know. I told you guys earlier during dinner that I've been talking with a guy who wants to like get this thing going with some chat GPT or something like that
Yeah.
and really kind of spit something out. I don't, like I said, right now we literally have to manually go in and place. I'll show you a picture in it, but we have to place points just on the inside of the rim to put it through the program to see that, or to prove that it's an ellipse, and that's really tedious. Like I do like 5 or 6 of them. Like, okay, I'm done with this right now because it's so tedious.
Well, it would even know, since it's all pointing at Michigan, it would just look all the way around that circle for everything with the different ovals pointing up
Yeah, and it's
towards
around
Michigan.
Yeah, it's around 1,500 kilometers from Michigan right here. And again, so we've got this is remember earlier I was talking about the bedrock geology of Michigan itself. This is the mitten of Michigan. This is where all of these things point. That's the Michigan Basin.
It caught a baseball.
It's almost just like a mitten.
crazy.
Like,
Oh my God.
yeah.
It's splattered all over the place.
Right.
What a cosmic joke.
Yeah. But the problem here, is like if you ask a Michigan geologist, they will get so upset about this.
Really?
They really do. They really do.
It's a real
They don't want to
mitt.
catch any
It's
flack.
a real catcher's mitt.
Why do they get mad about it? I don't understand that.
Because again, it invokes catastrophism, and they're like, no, that's not how
Oh,
this
right.
formed.
Yeah.
And we were talking about geologic principles a minute ago. The law of horizontality basically states that strata forms flat layers. Like if you go to you go to the Grand Canyon, you see the lines, you see the
Sure.
stratigraphy, and it's all flat layers all the way across. And all of a sudden, when they start talking about the Michigan Basin, now they say that, oh, well, here it formed bowl shapes. And so we have these bowls that form, and that's why we get what we find. And I'm like, no, that's not how geology works. You can't say that. That's not part of, like, it's not one of the, it goes against the principles of geology to say that. But a Michigan geologist will be like, no, that's how it formed.
Yeah, what about meteor impacts? What about the
Right.
Yucatan?
Yeah, literally we have like a bunch of third graders, all of these Carolina bays and all of these Nebraska rainwater basins.
They're all pointing
right to the catcher.
Oh, 1,000,
Yeah.
1,500 kilometers? What a splash.
Yeah.
That's
Yep.
crazy.
Oh, and then the other thing too, and this is actually a paper that came out not too long ago. Their conclusion was off a little bit, I think, but this is showing a gravitational anomaly that's on par with the Chicxulub crater. It's literally a gravitational anomaly that something happened there, and it matches what happened over the Chicxulub impact. The
In the Yucatan.
in the Yucatan.
But it happened really slowly.
Yeah.
Right.
Yeah.
Because that's how things happen.
Yeah. And then they were invoking an impact here, and that's why they use this image in their paper.
That's amazing.
Yeah, it is. So I do think that obviously by looking at the evidence that is here, that there was something big that happened over this area.
What else could it be? Everything's pointing at Michigan.
It's just crazy. There's like 75,000 of these. That's what you said about 75,000?
Around 70, I think. Around 70,000.
70,000
Yeah,
pounds.
that have been.
And they're all pointing at
Yeah, and again, if you
pointing
go
at
back to some of
Michigan.
these pictures, I mean, some of these haven't been marked, right? So 70,000 have been actually like labeled and marked. And they're like part of the survey, and so you can go in, you can download the survey, and the azimuth is on there, the location, exact location, Latin longs, and all that kind of stuff. But there's a whole bunch of smaller ones that are like, I bet that one's not on there. There's a whole bunch of them that are not in there. So yeah, I definitely think that there was a major impact there.
Why aren't there any in like Indiana or just south of Michigan or Illinois?
Because a lot of those places were covered in glacial ice.
Oh,
at the
so
peak
it
of the
just
last
flew
ice age.
just past the glacial perimeter.
It depends on when it happened, right?
Right. I guess
So
that's true.
so if it happened during when I think it did, they could have been some there. There could have been some there.
Oh, but then they got eroded.
Yeah, glaciers
over.
when they grow, it's like a giant bulldozer, and it just kind of like scours the ground. 786,000 years ago, that was 7 or 8 ice ages ago.
Oh, so the
ice age
glaciers
cycles ago. Yeah,
they would have reformed and kind of smoothed out.
7 or 8 times.
Yeah.
Where's your evidence? Where's
Yeah.
the crater?
But so the glacier never
Yeah.
reached all the next glacier periods in time never reached down to to the Carolina Bays.
The last glacial cycle was one of the most severe. There's a couple lobes I think that may date back older, but the last one was a really big cold ice age, and we had a really long, the terminal moraine, the last push of the glacier, which actually in some places during the Younger Dryas it pushed down even more. Like it was melting back, and then they reformed and pushed down even more. But yeah, that everything like in Canada and Nebraska, not Nebraska, but like North Dakota, all those up northern states, they were buried in glacial ice during the last ice age, and so you're not gonna find anything
because it got plowed over.
Yeah.
Okay.
Yeah, and there are some like oriented lakes that are in some of those locations, but they're formed from my presentation last year at the Cosmic Summit was pseudo Carolina bays, and so I focus on some of those like pro-glacial lakes, like right at the edge of the glacier, water pools up, and they form some really interesting elliptical or ovoid shapes. But when you do your method of trying to prove ellipticity, they fail. So again, Antonio Zamora and I actually we don't agree on time. We don't agree on anything. And what I really like about this is, even though we don't agree, like we argue about timing all the time. And anytime he says, he just put out a video yesterday all about the Younger Dryas. And I'm like, oh, God, I have not gotten anywhere with this guy. But we spent about 8 months working together really close. And we came up with a paper knowing that we disagreed on the timeline, but we agree that there was a major impact into the ice sheet, and that's what we focused the paper on. And like I said, it was very tedious of going through and marking these, and just we I think we published a dozen of them, but we have a database of way more than that.
Oh,
And,
yeah.
there's some.
Machine learning is great for stuff like this.
Yeah, there's got to be a way to
This
do
can be
so
automated.
easy. Yeah.
Yeah.
Yeah, maybe we can help you figure that out. I don't know if it sounds like you already have a software guy on it, but
If you guys have an idea, let me know. Like I said, I get a lot of people that want to help, and then it fizzles. And
yeah,
there's no help.
yeah, I got to know
So-
exactly what I'm trying to solve.
Right,
So
right,
if you're
right,
if I
right.
get a picture and it's like label these ovals, maybe I can figure it out. Yeah.
Yeah. But that's basically what we're saying is like a conic section is an ellipse. Like one of the conic sections is an ellipse. There's a circle if it goes straight down, right? You've got the parabola is a conic section, but one of them is an ellipse. And so that's kind of the basis of that paper was that an ellipse could be a conic section, and that could be from something entering, even if it's the energy of something entering the ground, that we would end up with these perfectly shaped ellipses. And that's what we published. And like I said, it was actually a pretty big deal. It was
Cool.
Yeah,
put it
congrats
together.
on getting published there.
and two guys that don't agree,
Yeah.
to get together. And that's what we need to see more of, man. We need to see more researchers putting aside their differences. Let's focus on the stuff that we do agree then. And then, if it sways you one way or the other, great. If it doesn't, okay. Well, we tried, and we still have something that's added to the scientific community.
It
So
seems like you could also just say it could be both. Like, why couldn't I don't know much about papers, but it seems like you could just say, well, we think is this or this. It's inconclusive, but
Yeah.
both are plausible.
right.
In a way that's okay.
And that's kind of what we did. So we focus on the physics because we think that's pretty solid.
Yeah.
Right. Or at least it's testable. And that's the
Sure.
point of science is if you disagree with me, fine. Show me. Write a
Yeah.
follow it up. Write another paper, because that's the thing. Like there's been nothing published. There's been a couple papers here and there. And they're usually just reiterating what was done back in the 70s and 80s. There's been no new science on Carolina Bays for I don't know how long. And so I was okay, let's do this. Let's write a paper. And so having something peer reviewed in a journal is a big deal to us. And I hope it gets a lot of attention, and I hope that it sparks other research. Like my goal is to have college grad students pick this up and run with it. So I can go back to fishing. And I mean, you guys, you're in my bunker down here. I love camping and hunting, and
Yeah.
I'd love to get back into that more.
Yeah, definitely.
Instead of staring at stupid ellipses on
LiDAR.
colorized LiDAR.
But I can see why you can't get away from it, because there is just this splatter pattern across the country, basically, that is
Yeah.
like, it's telling some story, but what is
Right.
it?
Yeah.
It's very strange.
Yep. So in my opinion, again, we're really looking at when did it happen, because that's a whole nother debate. It's a whole nother discussion. If you do agree, then when did it happen? Younger Dryas or
Right.
mid-Pleistocene, right? And that was what we talked about. We briefly talked about it, like at my discussion this summer at the Cosmic Summit. Tony handled the physics. I'm fine with him doing that, because I would screw it up somehow anyways. And then I talked about the timeline, and again, he knows that I disagree with him, and I can present his evidence well. I understand where he's coming from, because I was in it too, for a long time. Because we have 12,900 years ago. We had some things happen, right? We've got the black mat layer that's there. So there's a cosmic event. The platinum that they find, shock fractured quartz is a new addition over the past couple years.
Cool.
That was always, we call them the shocked quartz mafia. It's a group of geologists that are like, if you don't find shocked quartz, there was not an impact. Get out of my face. And they're like really rude about it. It's like, you don't have any shocked quartz?
They sound like they're
Get
awesome
out.
at parties.
Oh, they're off. There's actually there's a discussion where Randall Carlson got heckled off stage at a discussion up in Atlanta at the from one of these guys, one of the shock quartz mafia guys. It was coming at him, was like, you don't know what you're talking about, and literally like distracted his entire discussion that night. Yeah, his
Wow.
conversation. Yeah, it was pretty bad.
Who are these guys? Reach out to Austin and Matt. We want to talk to you. Shock
Quartz
Quartz
Mafia.
We need to talk to somebody in the Shock Quartz Mafia.
AustinMatt.com/shockquartzmafia. Leave us a note.
So again, 12,900 years ago, we have a 10% biomass burn. So there is some burning involved. It's not necessarily part of the black mat. One of the speakers at the Cosmic Summit this year, Dr. Joanne Harris, she talked about this because they did a lot of lake cores and find burned evidence in lake cores that date back to the Younger Dryas. So there is an event, there is a burn layer in ponds there.
So the black mat is sometimes burn. It's
like I said, they found like at least a 10% biomass burn.
Oh, okay.
But
because I heard there was a lot of fires in the whatever that impact was.
But the black mat where they're finding all this proxy evidence was mostly like that algal layer.
Okay.
Yeah. A Y chromosome bottleneck. We do see that there was, which is also, you guys were talking about, some of the stories that come out of the Younger Dryas, with the Atlantis, and one I find really interesting is the Amazonians, like the women tribes of the Amazon. There's a huge Y chromosome bottleneck that happened around the Younger Dryas that's unexplainable, and it's like, does that give a little bit of evidence towards the women tribes of the Amazon?
Because there were no men around. There's none of our chromosomes.
Yeah, so there's a pretty big bottleneck that happened there, and Antonio has drawn attention to that too. We also talked about the Clovis culture collapse. And his big, like what he thinks is a smoking gun is the inverted stratigraphy. There is a couple times where they've been doing their Clovis research. Archaeologists will use a dating method called optically stimulated luminescence dating, where you can actually detect the last time grains of sand have been exposed to sunlight.
Oh yeah.
Right. And so they can go through and they test grains of sand to see when the last time they were exposed to sunlight. And we actually, in a couple of these crater rims, a couple of these Carolina Bay rims, there's an inversion of stratigraphy where you go, like if you're going down, you see 5,000 years, 9,000.2 years, 11,000.5, 15.5, and then it goes back to 13.1, which is like right around that Younger Dryas boundary. And Antonio's like, well, the only way that can happen is if you had
gets splashed up.
That's right, and it flaps over, right?
Yep.
And so he uses this as evidence that these were impacts, and it was the overturn of the rim being formed is why we have the inversion of the stratigraphy. And this has actually been found twice. I think I included. Yeah, there was actually in a Ted Bunch journal. This was not part of his actual research. It was like deep in the appendix, where there was some overturned stratigraphy in that data as well.
What's the significance of that? It was in his appendix. He ignored it or something? Or?
It was. I don't think it was crucial to the paper.
Okay.
They included it because they tested it, but it wasn't part of what they were looking for.
It was just the data.
Yeah.
So they also that's been shown in two different data sets, basically.
Yeah, basically. Yeah.
Okay.
Yeah. Now, and I find that's pretty interesting. Now, something that Antonio doesn't like to talk about is that there are other ways that you can get inverted stratigraphy. And I think one of those ways, I think that all of the dates that they get out of here are erosion events. And the Younger Dryas would have been a major erosional event. These guys agree that it was a major erosional event at the Younger Dryas. And sand being blown, if it's blown at night, you're not going to have the resetting of the optically stimulated luminescence, the resetting of the quartz.
Oh, at night.
At night, yeah. If it's blowing at night, so if it's not like the wind doesn't blow at night. In fact, it actually blows harder at night, and that could be why we're finding inverted stratigraphy. Is that they just had a bunch of sand being blown around when it was dark. They're testing it, and it has older dates, and then it goes back to younger dates, and so I don't think it's a good method to determine formation of a Carolina Bay. I think it does a really good job of showing erosion events, like big erosion events. The evidence as they go deeper into these Carolina Bays, they find a couple other dates. There's like 3 or 4 of them that go into the late Pleistocene, but OSL is only good to around 300,000 years or so. And again, if this goes back, if these elliptical shaped depressions date back to close to 800,000 years. There's really no good way to test that with age, with these age aging methods. So I like I said, I think they found a really good way of determining erosion events, and that's the Younger Dryas was a major erosional event. Again, we have a bunch of evidence also for a mid-Pleistocene transition event. Again, this is where, and I'll show you some images of what I saw in a second, but the A tectites I think are really cool. And again, I can show you guys a couple of them. I don't know if you can you reach into, it's in one of the pockets. Yeah. Yeah, actually.
Oh, cool.
Yeah, I got these from Hal Povenmire. Hal is like basically Mr. Tectite. He wrote the book on tectites.
Hal Povenmire was.
Yeah.
That's so strange. Wait, hold on. How was the guy who's supposed to have mapped the moon for NASA back in the day, right?
Yeah.
And then he gets called down to live with Chris Bledsoe, who can call orbs to him at will, it seems.
Supposedly, yeah.
And he investigates Chris's family for years,
Yeah.
sort of living alongside them and visiting them all the time.
Mm-hmm.
And you're saying he's also the tectite?
He's the tectite guy. Yeah, he's everywhere.
That
He's
is
everywhere.
so strange.
Yeah,
Wow.
yeah, it really is. My wife actually met Hal. He was at a gem and mineral show in Jacksonville.
No way.
And my mother-in-law is huge into gemstones and fossils and things like that. Anything like that. They actually go out to Tucson, Arizona, and they would come back with boxes of
The
stuff.
Mecca.
Yeah.
Of gemstones.
Yeah. So she was at a gem and mineral show in Jacksonville, and there was a guy. There was an older gentleman there with a bunch of rocks in front of him, and he had a map of Georgia behind him, and the map had speckles of where some of these rocks, because the tectites that you're holding, they find them in Australia and in Asia, which I think is related to the Carolina Bay story, which is basically it's melt glass. If you had a strong enough light, you should be able to see through some of those. You should be able to see like all the way through them. We do find tectites in Georgia that actually came from the impact that hit the Chesapeake Bay around 55 million years ago.
Whoa.
Yeah, about 10 million years after the dinosaur killer, there was an impact into the Chesapeake Bay that sent melt glass from that impact site onto the soils of Georgia, and then it was covered up, and we actually find they find them in certain counties in Georgia. The reason why my wife went and introduced herself was because his map had a little spot of missing tectites, and she just happened to say, hey, my father has family property right in that spot right there. And he was like, really? Because if we could find some tectites there, that would like completely expand our map into a whole nother county. So he was really excited to meet and talk with my wife. And he actually, like I said, he gave her the tectites from Australia or Asia. And she put him in contact with me. She got his number. I called him. We tried to set up a couple dates to go hunting for Georgiaites. That's the ones different from those. They're actually a really pretty green color.
Cool.
Yeah, they're really kind of neat. And we never could work. He was probably visiting Chris Bledsoe, and we could never get it to work out. And unfortunately, he passed away, and we never actually were able to get it done. So had a couple really good long conversations with him, but never got to meet him in person.
Did you ever get to ask him about Carolina Bays in general?
I did not, but so the reason this becomes an important part of the story is because when I was talking with Tim Harris, who's on this page right here, Tim, like I said, he's an engineer. He worked for Boeing and Lockheed Martin. He's the one who has like done the projectile trajectories of the A tectites and has traced them back to Michigan, which I think is pretty fascinating. And he contacted the tectite guy. He contacted the guy and be like, "Hey, can we talk about these tectites?" And he said that Hal Povenmire was coming around. He's like, you might be right, man, because there's also a really neat chemical signature of the A tectites that matches the sandstones of Michigan. So he was like, you guys might be onto something on that one. And so he was really kind of encouraging them to continue their research and to move forward with it. And Tim Harris has some really cool Hal Povenmire stories. And so this was probably 2019, I guess, 2018. He was coming down to Georgia. He contacted George Howard to see if there's anybody in this area. He was actually going to Savannah. His son was going to get onto a yacht and be a first mate as they work this yacht back up to New York City. and it was COVID. No, it was 2020 because it was during right in the middle of COVID. And I was like, dude, just kind of. He was super worried about it because of COVID. And I was like, dude, just come on. We're not even wearing masks down here. Let's get down here in South Georgia.
It's a free country.
Yeah, get down here. And he was actually super surprised about that. He got here and he was really kind of weirded out. And I was like, dude, back then I had a pop-up camper, and I was like, just go stay in there if you are more comfortable. And but yeah, he stayed the night. We were right out here on the back porch talking about tectites and Hal Povenmire and Carolina Bays. And at that time, I was not on board with his timing or how they were created. So I completely disagreed with him at the time. But his discussion with me about tracking the tectites and using the physics behind it, I was like, in the back of my mind, I was like, this guy actually sounds really confident, and it's backed up. He knows what he's talking about. And over time, I looked into it more and more. I was like, and then I had that discussion with Michael Davies about the sandhills and the old ancient barrier islands, and that's when I was like, okay,
got to you.
That's what got to me, right. So throughout that research, that's where I started looking up. These are actually this timeline is ice ages as we go back in time, right? So we are actually right here. MIS, it stands for marine oxygen isotope stages. They get these from the ice cores that we get from Greenland and Antarctica. Greenland only goes back so far, and then they have to go back deeper in time using the Antarctica cores. And so we are right here at MIS1. That's our current interglacial right there. Here we are way down here. This is the peak of the last ice age, and the Younger Dryas would have been like right around here somewhere. And then you could just kind of go back and look at the peaks, right? So this was the last interglacial, and that was when we had 30 feet of water above us, from where we are today. Like where we're sitting in this room, in the bunker, we would have had water, 30 feet above our heads, or at least, 25 feet above our heads, because there's literally a creek behind here that's at sea level, right? And so that was the last time sea levels were higher than today, and they were 30 feet higher today. And the time before that was 400,000 years ago. And like I said, we actually have well-dated beaches that were formed during those interglacial period times. We had other ones that didn't quite get up to our level, and those old beaches are covered up in our most current, ocean. So we don't find them anymore. Sometimes you find like shoals, or you find like a sandbar that was part of an old barrier island, but there's not much evidence. It's been worked over by the ocean, right? It's flat. If you go to the beach today, it's flat, right? And if you follow that into the ocean, it's super flat all the way to the shelf. And looking at that, this is where, like I said, I pulled up this image to show Michael Davies the ancient barrier islands using his LiDAR. And I got this information from a Valdosta State University field trip guide, where they used to take their students down to the beach, and then they would work their way back to the college, and going over these old ancient barrier islands. So you actually see where and when they were formed as you make your way up. So when I clicked on the image, this is the one that I was like, hold up, wait, hold on. So we only find Carolina Bays on tops of those old barrier islands all the way back. Where are the rest of them? Why are there not Carolina Bays all in this area here? This is all high and dry today. There are towns there. There's houses and stuff that are in a lot of that area. But when you click on it, like I said, all those red dots are Carolina Bays. I'll show you some other examples, but this is panned out because this is the one that I use.
Way high.
But there's a lot of area that should have Carolina Bays if they were 13,000 years old.
It's only on the highest points then?
It's only on the highest points.
It's on the highest points.
Mm-hmm. Yep. So again, I this is where I really kind of focus on, is around the Myrtle Beach area. For one, a lot of people have been to Myrtle Beach. They you go to the beach at Myrtle Beach, and and it's actually, if anybody that goes, it's a steep drop off to get to the beach. Like there's a sand dune right there, and it goes right down. That sand dune is an old barrier island. It's an old ancient barrier island, and the ocean is actually working away at it right now. Like we're actually seeing the process happening today at Myrtle Beach. So I like using that as an example. And we have really good Carolina Bays right up here. These are actually some of the Carolina Bays that were from that original 1930s picture. same area around Myrtle Beach where we find those. And when you click on that LiDAR again, you can clearly see where the Carolina Bays are, which you can clearly see them without the LiDAR. Like, right, we see them in these areas right here. That's the Heritage Bays Preserve in the Myrtle Beach area. But when you click on the LiDAR, you can really see where they are and where they're not. And it's the areas where they're not where I'm like, okay, why are they not there? That's where the ocean was 125,000 years ago and 400,000 years ago. And I think that they have been washed away. You can see some. You asked that question about, are there some Carolina Bays that are like truncated? That's the word I like to use, is truncated, because they have there. Look, there's like one here that are all truncated. There's one right here that's actually, you can see the rim heavily eroded right there. There's actually a series of bays right here. I think this is really important because these Carolina Bays would have been on the backside of a barrier island. And just like today, you have the beach on the windward side. The leeward side of the island is an estuary. It's like a salt marsh. And 125,000 years ago, this area right here would have been a salt marsh. And a really easy way to test that, maybe somebody can go do it tomorrow, is to dig in some of these Carolina Bays and find pluff marsh mud, find mud from a Carolina, or from a salt marsh estuary that would have been there the last time sea levels were higher than today. I think you're going to find.
So you just dig in and you find a bunch of salt, basically.
You don't even need to have like a core, like spend all the money and just bring a shovel, dig a hole,
find salt.
And if there is black marsh mud, then we know that Carolina Bay was there and it was filled in and it survived. It would actually preserve the Carolina Bay over time. So that's a really quick and easy way to kind of prove that. I haven't done it yet. Need to go.
You said only a couple cases of inverted stratigraphy were found, or is it in a lot of Carolina Bays?
There's been two that have been found. There's a push, like one of the things that Antonio Zamora brought up was, can we just check some more? Scientists.
Yeah.
Can you guys go check some more?
Oh, so it could be the case all of them are like that.
It could be that way, yeah. And like I said, again, I don't know what it would prove, because is it proving erosional events or is it proving?
No, I think the reason it's interesting is because you mentioned a guy, Hal Pavemeier, who studied a place that had inverted stratigraphy and pop marks all over it, which was the moon. I think it's the only other place I've heard of that has these pop marks and inverted stratigraphy, because they say that the older layers of dirt on the moon are younger.
The deeper layers of dirt are
younger
than the top layers.
That's what I've heard. Yeah. It doesn't make any sense. Yeah. And so why is this guy studying? I think there's a conspiracy that's about to blossom out of this. And I hope to be the one to coin it.
Take it. Run with it. Like I said, I want to go back to fishing.
Yeah, that's right.
You guys do it. So, yeah. I like that, though.
There's something going on there.
I think that there is a story behind Hal Pavemeier, and unfortunately, like I said, he's not here anymore.
Yeah,
so
right.
And he was such a secretive guy. Like, the only stories that I've gotten about Hal is from personal discussions with people that knew him.
Yeah.
Like, there's nothing. If you try to look up Hal Pavemeier, you can find nothing.
Well, Chris Bledsoe said he worked for the CIA, right? That's who he was working for when he was investigating Chris.
Is that what he said? I don't know. I know he worked for NASA.
I think that's what I've heard.
Yeah,
okay.
He was working for NASA when Tim was talking with him too. So I think it was kind of like one of those, he's still maintained his NASA privileges or whatever. I don't know if he was actually getting
nothing with the CIA, just
because like I said, he was selling rocks at a gem and mineral show.
Right, yeah.
So it could have been just like a retirement thing. I don't know.
Right.
But and like I said, I don't even know if he was selling them. He may have just had like a informational display set up, and he gave my wife a couple of those, and they're worth.
These are so cool.
They're worth some money. Yeah.
So these are actually from Australia, that area.
Yeah. Those are probably from Asia. Yeah.
Okay.
Yeah. That's where they find a bunch of them.
It looks like they have little pock marks in them too, actually.
Yeah, the pock marks are really cool. So one of the discussions I had with Tim Harris the night that he was here was that those pop marks are plasma arcs, like stratospheric plasma arcing. And when I was at the Cosmic Summit just last month, with you guys, I had a discussion with Dallas Abbott, and she's there. She's there as the she's a tsunami expert. Like, she's big onto mega tsunamis, and she brought up stratospheric plasma arcs because the last big event that we see, like stratospheric plasma arcing, was the Hunga Tonga volcanic eruption that occurred in the middle of
1908.
no.
that's
The Hunga Tonga happened like 2 years ago, 3
That's
years
right.
ago. Yeah, it was like 2020.
Yeah.
But it was such a big deal. Like, it was such a large eruption that actually started under the ocean. And the eruption was so big and so tall that it sent ocean water all the way up to the stratosphere. That's huge. That's a big
Wow.
deal. And the amount of lightning that caused to happen, which is plasma, the amount of lightning arcing that happened from that eruption um, was actually causing micro tectites to form because of the eruption causing that to go all the way up to the stratosphere. And she was looking for the plasma arcs and the micro tectites in the tsunami evidence. The tsunami washed up from other places. So she was using that as a proxy evidence for tsunamis, is using that plasma arcing on tectites, which I find interesting too. So
Awesome.
It is interesting.
yeah. So I just had a couple other examples that I want to show you guys. Again, I don't see any way around, a younger date when you start looking at some of these pictures where you see some of these that are literally, this one here had water go into it, stand in it for a while, and then wash back out during the time of the last interglacial. It's not like I oftentimes look at people that bring up tsunamis. Speaking of Dallas Abbott, like, well, a tsunami could have done that, and that's not how tsunamis work. They're not going to go right up to the last shoreline and then wash back out. You would see like ribbons, or you would see a lot of these really big tsunamis. They're so big or so high in elevation because they're rushing up a valley or something like that. And so you end up with these long ribbons. You don't see like the whole coastline washing up, and
Yep.
Yep.
Makes sense.
Yeah. So anyways, we've got these, they're all truncated, and they this is a good example. We, earlier we're talking about, Camp Lejeune. This is actually the location of Camp Lejeune. This is one of their, bombing or their artillery ranges. And when you click on the LiDAR, you see that artillery range is actually halfway in a Carolina Bay that was truncated right in half.
Wow.
And you have that whole rim right there. And there's also a couple, like this one here is just like a little tiny corner of one. There's, a couple other ones there.
It's compelling.
So, and again, you can actually, if you understand the geology, you can see that you go up to this peak right here. This is the peak of where we're at, and then it goes back down into the it might be the Waccamaw River or something that's behind. I can't remember which river that is that's back here. But it goes up and then back down. So all of this right here was under the ocean as well. Not the ocean, but it could have been a big bay like the Chesapeake Bay today. Yep. I mentioned earlier about the Delmarva Peninsula being like an exception to the rule, because we do find that these are, see how they're all in blue? That's not quite above that 30 feet mark. And so these areas, but this whole area has been sinking down. We also see some down in this area right here, which was on the estuary side of a barrier island. And then on the opposite direction, we have places like Charleston, which is actually known for being very tectonically active. They have earthquakes in Charleston. You mentioned 1908, but I think it was actually 1890 something. There was a big earthquake in Charleston. But that's because that area is slowly rising. It's actually rising up. Instead of sinking like at the Delmarva Peninsula, this area is rising. And so there are areas that should be covered in Carolina Bays, regardless of when they occurred. But this area has been rising for quite a while. And I'm guessing it's going to be around 786,000 years ago that's been rising up, and we don't see those anymore. So, but yeah, you see all the high elevation areas. You see the red marks, which are, if we zoomed in, you would see that they're Carolina Bays. So
it reminds me of like how my skin is freckling because I'm getting older. It's just there's so many freckles on my skin, and when you look at these pictures, it's like the whole country must have been just blasted by something. Wasn't age, I guess.
Of sorts.
Of sorts, yeah.
Man, this is so comprehensive.
Yeah.
I hope so. I've been harping about this for 10 years.
Yeah.
I told you, the 2015 is when I kind of decided, after hearing Randall Carlson on Joe Rogan, and I was like, I'm going to start to focus back on some of this stuff that I was interested in back in the early 2000s. And my mind has changed. I've gone through this whole process. I still think that this was an impact. I think that it was a big deal. I think it was a bigger deal than the Younger Dryas. And I think we're going to start finding that. I think once we kind of start focusing in on some of these impact, because we know that there was a big impact that happened then. Literally, there are black glass rocks scattered across Asia. And once we start to really look, we're going to find that this was a big deal. The Carolina Bays were part of that. And it was there's going to be a lot of evidence, I think, that are going to support that eventually. We just have to get there, 13,000 years ago, we haven't even solved that one yet. So
Yeah, right.
and I'm fine with let's focus on that. That's kind of what I'm doing right now too. Is if this separates it from the Younger Dryas, sure, let's do it. Let's separate it. We can focus on it later.
That's
What I
right.
mean?
Well, the mystery of the Carolina Bays will live on, but I really appreciate the work you've done to help us try to get a step closer. It's also just a cool example of like thought leadership. Thanks for thinking your thoughts and leading.
I appreciate it. Thank you.
Yeah.
Cool. Thanks for being on, Chris.
All right.